doing an integrated cost and schedule analysis really lets me get to. And that is done through the scatter plot. So when I look at my overall project, I can look at it normally if I'm working in two separate systems, I can look at my distribution on a cost basis, or I can look at my distribution on a schedule basis, but I have no way of looking at both of them together. Now, the thing is, if I complete my project on time, but I'm over budget, no one's going to say I had a successful project. Similarly, if I'm on budget, but I'm over time, no one's going to say I had a successful project. And what I really want to understand is, how do I get success in both? So when I look at this, what the system tells me is, let's go back to the distribution graph for 1 second. What the distribution graph tells me for my overall project is that my deterministic value has a probability of success of 15%. So I'm 15% likely to bring my project in on budget. If I look at it on a schedule basis, it tells me that I'm 8% likely to bring my project in on schedule. Now, when I look at the scatter plot, it tells me that I'm only 2% likely to achieve both cost and schedule. Okay, so what does that mean? Well, what that means is, although I have a 15% chance of being on budget, which essentially would be represented by this horizontal line here. So 15% of the hits are below this horizontal line, which represents my budget. I had a 15% chance. So 150 of these 1,000 dots achieved my goals from a cost perspective. Now, only 8% of the hits showed me being successful on a schedule basis, and that's represented by this vertical line. So everything to the left of the vertical line, so quadrants 1 and 4, if we were to count them anti-clockwise, all of these represent 80 iterations where I was successful in achieving my schedule. However, overall, between those two, I'm only 2% likely to be successful. Well, what I really want is I want a joint confidence level, or what we call the JCL, of 70%. I don't want 70% in one and nothing in the other. I want to be able to report to management exactly where I need to be to have a joint confidence level. Now, to do that, you'll see that there's a color coding here, and up at the top it says, okay, your joint confidence level of 0 to 20% is in green, 20 to 50 is in yellow, 50 to 70 is in orange, 70 to 100 is in red. So I said I wanted a joint confidence level of 70%. So in order to achieve that, I need to be right on the border between the orange dots and the red dots. And you can see that let's just follow the first line of red dots. If I hover over one, you see that's slightly over 70%. But if I follow this, you can see that it's a vertical line that transitions down here to a horizontal line. Now, when it's vertical, that basically means that I can spend as much money as I want, right? I can spend more costs, but I'm not going to save any time. Similarly, when it becomes horizontal, the system's saying, okay, you can give up as much time as you want, but you're not going to save any money. So the project team, though, can manipulate their targets within a range here where there's a curve. So where it goes from being totally vertical, it curves down and becomes totally horizontal. And in that area, or that continuum of points, I can make some trade-offs. I can say, okay, I can spend a bit of money and I can save some time. And so the project team can decide if it's worth spending time or money to make sure that they're on that joint confidence level 70% line. Some people call this the JCL necklace because the dots look a bit like a pearl necklace. But the nice thing about this is it tells me exactly what trade-offs I can make as a project team. So I can give up some schedule to save some cost, or I can spend some money to save some schedule. And it gives me that ability to really understand those trade-offs between the two. And you can't do this unless you do everything in one system.